We're on Kerrera Island, and you can see Oban behind me. You can see that I'm standing on really quite a flat ground, maybe 10 or 15 meters above sea level here. And behind me you can see a very similar raised ground on the island, and over the other side of the sound you can see where that house is on the land there, and all the way along this kind of platform that's all about the same height here. This is a wave cut platform. So it was down at sea level, and it was the erosion, tidal erosion and wave erosion cut this platform. And that beach has then been raised. So we're on a raised beach here, and around here, around the west of Scotland, the West Highlands, you see these raised beaches. They get up to about 30 metres high. And they were at sea level in the past. During the Glacial maximum, maybe 100,000 years ago, the thickness of ice was enough to load the land so that it sank down into the mantle. Okay, we have perhaps a kilometre of ice here, something like that, several hundred metres, a kilometre of ice. When you weight that has about a third of the weight of the mantle, so it should sink down by about a third of the depth. So we should actually see 300 metres of sinking. Once the ice goes away, that all comes back up again. So why have we only got 30 metres of movement? And that's because the mantle is not a liquid, it's a solid, and it has a very high viscosity, so it flows very slowly. So still, the land is actually coming up, and we can use the rate at which the land comes up to work out the viscosity of the mantle. But it's still rising now, so we actually use that from round here and from around Scandinavia to work out what the viscosity of the mantle is. So this is a really nice example of a raised beach that was down at sea level during the last glacial maximum.